Hi geography class and Dr. Yeager. My name is Amanda Gleba and I'm here today at Cathedral Rock Nature Park and Leon Valley Greenway. This is part of the Howard W. Peak Greenway Trail System, which is 80 miles long. In this section today, we're going to be exploring the geography to see what we can find applicable to the nature. Here alone, we can see an elevation change of at least 40 feet. So let's go see what we can find. A dried out stream bed, which is also called an ephemeral stream. This stream, you can tell that it was here because of the dip and the U in the ground, and you can see that because of the water that was running through here at one point in time, there's erosion in the ground as well as a deposition of these branches and other things. We can also see by looking at some of the rocks that have been deposited through the area. Right here, we have further evidence of erosion. We can see that there's this tree here that was once rooted in the ground, but because of erosion and fluvial processes with water, this tree eventually uprooted and fell over. Go. Let's take a look and see what we can find over here. When we take a look at this rock here, we can see a few different processes. We know that there's several different weathering processes. There's biotic weathering, chemical weathering, and physical weathering, also known as mechanical weathering. Here we can see evidence of biotic weathering with the trees growing up through the rocks, as well as physical weathering, where we can see where somebody may have stepped on this or broke the pieces off. And then of course we have chemical weathering, where we see the change in discoloration in the rock formation. Well, looks like over here we have another ephemeral stream bed, or dry stream bed. Let's go take a look and see what we can find over here. So we can see here further evidence of weathering. Carbon dioxide, when dissolved in water, creates carbonic acid. Carbonic acid is especially good at dissolving limestone. And here we can see evidence of that dissolution right here with these little caves that are being formed through this area. Now, sadly, they're too small for us to get into, but if we get up close, we can see that they do go much deeper in. Here we can see another ephemeral stream. They seem to be very abundant here in the area. If we look down, we can see a number of very smooth rocks and very small pebbles that have been moved through the area via siltation, which is going to be the bouncing across the stream bed, or traction, where it's just slowly pushed across the stream bed. There's a number of these rocks in the area, and they all have different textures. Some of them are rough, like this, where we can see they've been broken down. Again, this would be the breakdown by carbonic acid, or they're very smooth from the repeated water rushing over the top and the velocity of the water. As we continue to explore the topography of the area, we can see another phenomenal example of biotic weathering, where the tree has grown underneath this rock formation and has started pushing the rock formation up. And of course, essentially breaking it in half, where we can see this portion down underneath the tree, while another portion is on top, sandwiching it. Here we are in yet another stream bed, but this one's a little bigger. And as we take a look here, we can see the process of erosion from when the water has flowed through here. In addition, we can see a lot of mass wasting occurring, where the rock formations are creating these big divots and holes. And down further this way, we can see another example of mass wasting, where these rock formations have fallen and left these gaps underneath, almost like a cliff or a cave. We all know that water is a crucial element in the process of erosion and weathering. As we can see here, we can see where the water is down lower and would have a higher velocity. This area is very smooth. This is also physical weathering from people walking through the area just as we are. However, if you look higher up at these sections further over here, these are not nearly as smooth because the water does not frequently get this high and therefore does not erode this area or weather this area as often as we see down here. We can see further evidence of traction and siltation because of the scraping that you see across the bed of this ephemeral stream right here. You can see it going all the way down, which you would see if it was raining and the water runoff was going down into the stream, it would all flow this direction, which is consistent with the scrape marks that we see down here on the stream bed. Feels a little like deja vu. Here we are again, here in another ephemeral stream bed. Though we can see evidence of standing water, and as the rain falls, the water would rise through this area. As we come this way, we can see the erosion on this side, and it begins to come this way and turn. We would consider this area right here the point bar, and that's why we see more evidence of deposition of rocks than we do on this opposite side. So if we look, we can see that there's more erosion here and more rocks than we see over towards the side, which winds outwards. And then it continues to meander through the area. Well, as the sun sets here today, it also sets on our time here at Cathedral Rock Nature Park and Leon Valley Creekway. Thanks so much, guys, for coming along with me and looking at all of these geographical processes for geography in my backyard.